All right, now let's look at a classic problem in databases. Deadlocks. What is a deadlock? A deadlock happens when different transactions cannot complete because each transaction holds a lock that the other needs. So both transactions keep waiting for each other and never release their lock. Let me show you. So here in MySQL Workbench, I'm going to close both these sessions and start over. I want to make sure there are no surprises. We start from a clean canvas. So let's open a new connection. And one more time. Now in our first session, we're going to use our SQL store database. Then we're going to start a transaction. In this transaction, we're going to update two records. First, we're going to update the customers table and set the state to Virginia for customer number 1. So where customer ID equals 1. Let me zoom out a little bit. That's better. Then we're going to update the orders table and set the status of an order to 1, where order ID equals 1. Now, don't worry about these values I've used here. It doesn't really matter. What matters is that first we're updating one record in the customers table, and then we're updating one record in the orders table. Okay? And finally, we're going to commit here. Now, before executing the script, let's copy this entire code and paste it into the second session, like this. But here in the second session, we should change the order of these update statements. So we update the orders table first and then the customers table. I will explain why this matters shortly. Now back to the first session. In this transaction, when we execute line 3, we're going to update customer number 1. This transaction will put a lock on this record, so other transactions will not be able to update this record, right? They'll have to wait. And this doesn't matter what isolation level we use. Earlier in this section, you learned that whenever we try to update a record, MySQL puts a lock on that record, so other transactions have to wait. So here we try to update this customer, but let's imagine, before line 4 is executed, another user starts a new transaction at the same time. This user is going to update one order in this table, order number 1. So this transaction is going to put a lock on this record. Then this line is about to get executed. So we try to update the same customer that the other transaction updated. So transaction number 1 already put a lock on this record. So we cannot complete this transaction. We'll have to wait for that transaction to complete. Okay. Now we go back to the first transaction and execute line 4. At this point, we try to update order number 1, but transaction number 2 already put a lock on this record, so we'll have to wait for that transaction to complete. But here's the problem. Both these transactions are waiting for each other, and they will never be able to complete. This is what we call a deadlock. So let's see this in action. Here in the first session, let's execute the first statement. Then we're going to start a transaction. We update the customer. Now we go to the second session. And once again, use our SQL store database. We start a new transaction. We update the order. So far, so good. Now we update the customer. This transaction is waiting. Take a look here. So we go back to the first transaction and execute line 4. Now we get a deadlock. So if you look at the output window, you can see an error here. Error 1213, deadlock found. In this situation, MySQL treats this transaction as the victim and rolls it back. So this is how a deadlock happens. Generally speaking, deadlocks are not a big issue unless they happen so frequently. If you're an application developer, you should write your application in a way that it can reissue a transaction if it gets rolled back because of a deadlock. Or you may just tell the user, hey, this operation failed, please try again. But there are a few things that you can do to minimize deadlocks. You can never completely get rid of them, you can just minimize their likelihood. Here are a few things. If you frequently detect deadlocks in two transactions, look at their code. These transactions could be part of two stored procedures. Now look at the order of the statements in your transactions. If these transactions update records in the reverse order, it's likely you're going to have a deadlock. That is the reason we swapped the order of these statements in the second session earlier. So to reduce deadlocks, you can follow the same order when updating multiple records. That's one solution. The other thing you can do is to keep your transactions small and short in duration, so they're not likely to collide with other transactions. If you have transactions that operate on really large tables, these transactions may take a long time to run, and then you're at risk for collision. If that's the case, see if you can schedule those transactions to run during the non-peak hours when there are not a lot of active users. So that's pretty much what you can do. And that brings us to the end of this section. If you found this section a little bit overwhelming, I totally understand. Quite honestly, concurrency is a fairly advanced topic, and it's okay if you're confused the first time you're learning about it. I personally had the same experience myself, and I had to look at several different sources to really understand concurrency. Trust me, you're not going to find any books or videos that simplifies this concept for you the way I've done in this section. I've worked really hard on this section to make it super simple for you. So if you're confused, just take a break and watch this section again from the beginning. I promise you're going to digest everything I've explained. All right, that's it for now. I will see you in the next section.